pick up in our notes where we left off from the last class, which was factoring by the greatest common factor. And remember, what we're doing is we're pulling out all those like terms that are familiar between both sets. So I'm going to start back over at example A, which was 4x squared minus 3x. And we want to factor out both the number and the variable. And so we know that the common variable here will be just our single x term. So we can factor out x out of both of these numbers. Now let's talk about if we factor out the numbers. Okay, so the only number that goes in between both of those is a 1. And from class we know that these two will be the resulting equation inside our brackets. We're going to have 4x minus 3. And then the x squared that we originally had reduces down to x. This x goes away because we just factored that out. And we can always check these by redistributing the 1x to both terms. Okay, look at b real quick. b is 10y cubed plus 20y squared minus 5. Okay, and that was 5y. Sorry. So what we have here, we know that each of these terms has a y variable, so we can factor the y out. We also can take the numbers and factor out a 5 from each of those. So 5 will go into 10 2 times, 5 will go into 24 times, 5 will go into negative 5, negative 1 times. And so if we pull out a 5y, what we have left over, we're going to put these as the new coefficients, so 2y squared, okay, plus 4y minus 1. And so remember, these become the numbers here, and then the exponents depend on what you factored out. So if we factored out one of these y's, we're going to reduce all of these y variables by 1. Okay, let's go to example C. I'm going to remove this now. This whole video is going to be over factoring by greatest common factor. So C is negative 12x minus 8 squared. Okay. And we know that the lowest variable term is x here. Both of those have at least one x, so we can pull that out. Now, I want to see what will factor into negative 12 and negative 8. Okay. So I know that both of these numbers can be divided by a negative 2. Okay. If both of those are divided by negative 2, then this number is 6, this one is 4. I can keep going on. At this point, I can divide each of these by 2. And this is 3, and this is 2. And so my greatest common factor here is a negative 4. Now, it's very important. If both terms are negative, you do want to pull that negative number out. If only one of them is negative, then it's safe just to leave it there. Okay, so we know that the greatest common factor here is 4x. So if I pull my negative 4x, these terms are going to be the resulting values. Okay, I'm just going to have 3 here because we've already removed that x here, plus 2x. And we reduce this x squared by 1 factor because we just pulled that out. And if I were to redistribute this in, and you can see from another color that if I were to redistribute this, okay, you would get negative 12x plus negative 8x squared. And obviously that reduces down to negative 12x minus 8x squared, what I originally had. So we know we're good there. Okay, D. D is 5x squared plus 7. Okay. Now, is there a variable term in both of the numbers? No, there's not. Okay. Is there a greatest common factor that we can pull out between 5 and 7? Well, that factor is going to be 1. And so in this case, this polynomial cannot be factored. Meaning that it's already simplified as much as it can be. Okay, we can't simplify that down anymore. Okay, E, example E. those have a b value, this is what I can pull out. And then I want to know, is there a common number between 5 and 9? Well, in this case, it's going to be just 1. So I can factor out a 1b, which you'll see in a minute that that's an understood b. What's left over is 5 plus 9b squared. Okay, once we remove the b, we take 1 from each of those. This reduces down from 3 to 2, and so we can simplify this as b 5 plus 9b squared. Basically, we're removing that term from both sets. Okay, last one on this page is f 90 squared minus 8 squared. Now, I'm going to go ahead and simplify this just a little bit more. This is the same thing as saying negative 64. So I'm going to simplify this pattern. Okay, so common numbers between 9 and 64 is just 1. Okay, these cannot be factored out. There is no greatest common factor besides 1. And since both of those do not have a d variable, this polynomial cannot be factored. Okay, we've got 2 more examples on the next page, G and H, and then that will conclude this video. Okay, so G is G is negative 18y cubed minus 7y squared. Okay, so let's talk about our greatest common variable. Okay, we have y to the third and y to the second. So both of these have at least y to the second. So we're going to be able to pull that out. Let's look at our numbers. Negative 18 minus 7. The only thing that we can pull out of this set of numbers is a negative 1. Okay, and by doing that, I'm left over with 18 and 7. So negative y squared is what I can pull out. What I'm left with is 18y plus 7. And you always want to double check this. If I redistribute this term to both terms inside the parentheses, what I will get is negative 18y cubed plus negative 7y squared, or negative 18y cubed minus 7y squared. This was my original answer or question. Okay. Last one on this page is H, and please feel free at any point, you can stop or rewind if you need to. Look at things a little slower. Okay. So let me move this up just a little bit. So what we have is the most common variable is this x squared. There's an x squared in all of these. Okay, so let's look at just the numbers. 8, 4, and negative 2. Now, I can pull a positive 2 out of all of these. This is 4, this is 2, this is negative 1. And so what I pull out is 2x squared. Okay, what's left over is going to be 4x to the 2. Okay, it reduces by that factor. Plus 2x minus 1. And I want to double check this just real quick. If I distribute this to both terms, I get an 8x to the 4 plus 4x squared minus 2x squared. And, oh, sorry, this is to the cube. And so this matches. This is good. It's very easy just to go ahead and do all of your checks really quick. Okay, so that takes care of factoring by greatest common factor.